Good morning, student. We'll continue with bending stress and shear stress. Today we'll solve three simple numerical. Again, basics regarding maximum bending moment. For simply supported beam, it's WL divided by 4. For simply supported with UDL, WL square divided by 8. For simply supported with point load not at center, WAB divided by L. For cantilever beam with point load at free end, WL. Cantilever with UDL or entire span, maximum bending moment, WL square divided by 2. Now today's problem. An unsymmetrical I section 300 mm deep is simply supported at ends and carries a load of 100 kN at center. If Ixx is 73.33 into 10 raised to 6 mm raised to 4, calculate the maximum span if permissible bending stress is 120 Newton per mm square. Bending stress, so here given D is equal to depth 300 mm, W load 100 kN, that is 100 into 10 raised to 3. Ixx, that is moment of inertia about xx axis, is 73.33 into 10 raised to 6. Bending stress sigma is equal to 120 Newton per mm square. So we have to find the span. So here we have to find here maximum bending moment M is when acts at center in case of simply supported beam. M is equal to WL divided by 4. We have just seen this in the formula. M is equal to W 100 into 10 raised to 3 into L divided by 4. Y is equal to distance of extreme layer from neutral axis, which is equal to D divided by 2, 150 mm. Solution to find length L. To find length L, Y is equal to 150 mm. From flexure formula we know. Now what is important is you should know this formula. Once you know this formula, you have to substitute all the value. M divided by is equal to sigma divided by Y. M is equal to sigma into I divided by Y. Now M is nothing but WL by 4. So you substitute the value. Then you rearrange it. L is equal to sigma into I into 4 divided by Y into W. Now in this formula you substitute the value. You get 4 into 120 into 73.33 into 10 raised to 6 divided by Y is 150, W is 100 into 10 raised to 3. Solving, you get answer L is equal to 2346.56 mm, which is 2.34 meter, 3.4 meter. Question number 2. To find modulus Z. Z. A simply supported beam of span 10 meter carries UDL of 100 kN per meter over its entire span. Calculate the modulus of section required if its bending stress is not to exceed 190 MPa. सेम फार्मूला यूज करना है, फ्लेक्सर फार्मूला जो यूज किया सब वही फार्मूला है, ठीक है. I divided by Y is Z. So let's see. Now given L is equal to 10 meter, W is equal to 100 kilonewton per meter, sigma is equal to 190 MPa, that is 190 Newton per mm square. Okay, so now this is type of beam simply supported with UDL on the entire span. So maximum bending moment is W L square divided by 8. Solution. We have to find first maximum bending moment. M is equal to WL square divided by 8. W is 100 into length 10,000 whole square divided by 8. M is equal to 1.25 into 10 raised to 9 Newton mm. From flexure formula we know M divided by I is equal to sigma divided by Y. Sigma is equal to M divided by, in bracket, I divided by Y max, bracket close, is equal to M. I divided by max is Z. Z is equal to M divided by sigma. Z is section modulus. You substitute the value. M is 1.25 into 10 raised to 9 divided by sigma is 190. By solving we get Z is equal to 6.578 into 10 raised to 6 mm cube. Third question. A beam 300 mm deep is used as a cantilever over a span of 1.2 meter. Calculate the intensity of UDL it can carry, including the self weight, if the bending stress is not to exceed 8 Newton per mm. Moment of inertia of beam about neutral axis is 4.05 into 10 raised to 8 mm raised to 4. Again, it's a cantilever beam. For cantilever beam with UDL, maximum bending moment is WL square divided by 2. Given depth 300 mm, length 1.2 meter, bending stretch sigma 8 Newton per mm square. INA, that is moment of beam about NA neutral axis, 4.05 into 10 raised to 8 mm raised to 4. So this is depth of beam, this is Y 150. First find maximum bending moment, which is equal to WL square divided by 2. W is you have to find out, so W into 1.2 into 1.2, that is the length, divided by 2. M is equal to 0.72 W kilonewton meter. M is equal to 0.72 W into 10 raised to 3 Newton meter. I is equal to INA is equal to 4.05 into 10 raised to 6 mm raised to 4. Given Y is equal to D by 2, which is equal to 300 divided by 2, 150 mm. Now from fractional formula we know M divided by I is equal to sigma divided by Y. M is equal to 0.72 W into 10 raised to 3 divided by I 4.05 into 10 raised to 8 is equal to 8 divided by 150. W is equal to 30,000 Newton per meter. That is the answer. So that is for the day, student. Thank you.